everyone, this is KP to MapG. Get rid of this gum here, alright. Well, I was going to do related rates. That is not true. This is a question from 2003. This is an AP question, and it is 2003 question 5, and it is a free response question, and I didn't want to write everything down, but there's a coffee pot with a radius of 5, and of course this is the coffee or whatever in the coffee pot. And of course it's in a right circular cylinder with height h, radius is 5 inches, and the volume is changing at a rate of -5 pi times the square root of 8 cubic inches per second. So we see that the volume is changing. What do we know about this volume? Decreasing, isn't it? Decreasing because this is negative. Okay? The volume of a right circular cylinder is V is equal to pi r squared h. Now, we got to show that dH over dt is negative square root of h over 5. Alright. Now, to do that, what we have to realize is this is not the volume here. This is the volume is changing. Is changing means that this is dV over dt. This is not V. V is changing. Okay, well, if it's changing, it's dV over dt. And it's at a rate. Now, this is -5 pi square root of h. Alright, I'm not going to worry about the units at this point. So we need to understand a couple things here. What do you know at any rate, wherever this radius is, will that ever change? Will the radius r ever change at all? No, in a cone it will, because it's conical and it's not upright or anything, so r does change and h changes both in a cone. But in a right circular cylinder, r is constant. So we have to remember that. R is constant. Matter of fact, if you want to, we can go ahead. I'm just going to go ahead and put it on the other side. V is equal to pi r squared h. V is equal to pi r squared h. So being that that's 5 squared h, you can go ahead and put that in there, because r is constant. You do not have to worry about, on a right circular cylinder, about doing anything with r. Okay, in a cone like this, r does change. See, here's 5. Let's say this is 5 inches here, and then that does change at a certain rate. A little bit less, isn't it? This may be 4. Okay, this may be 3 or 2. Alright, or 2 inches, whatever. It's changing. Alright, it's getting even smaller. There's a half it, so it's changing. The rate is changing over a period of time. And that's what you have to remember about r. In this particular case, it's not going to change, So this makes it a little bit easier to deal with. dV over dt. Of course, now this is just 25 pi. I'm just going to put the pi in the end. And the derivative of h is dh over dt. Now we already know that dV over dt is a rate. It's negative 5 something. Let me see what it says. Negative 5 pi square roots of h. Negative 5 pi square roots of h. Alright, so on this side we have a negative 5 pi square roots of h is equal to 25 pi times dh over dt. You'll see that? And now that becomes easy to find. Now I think it does say show that dh over dt. We want to figure out what dh over dt is. Okay, well, this is multiplying, so we're going to undo it by dividing both sides by 25 pi. Notice that the pi's will divide out. 5 goes into 25 5 times. So we do have it. It's negative h, square root of h over 5 is equal to dh over dt. And that's basically, that's one of the easier problems, because in this particular case your radius is not changing at all. The rate of that is never going to change. So we just leave it like that. That makes it simple. And sometimes, you know, with me, I would have done a product rule here and realized, oh, wait a minute, R does not change. And so that's another thing that you just have to realize. This radius does not change anytime, at any point when the water is going down, or if it were going up. In this case, the water is decreasing, the volume is decreasing at this rate here. Alright, when I see cubic inches per second, that is dV over dt. You already know that. And that's something you just got to remember. This is constant. I just squared 5 and got 25, and then I just had to take that derivative of h right there. And there it is. That's all you have to do on part A. Boy, I am so happy to have gotten this problem, because not only are we going to work with we're going to work with both separation of variables. Well, and that one was a kind of a related rate problem on A, and then we'll look at another thing too. B is really good. I love B in particular, and C as well. Not saying that A wasn't shabby, but there's some things about this you just have to think about, okay? And so that works out fine. And so anyway, that's all I have for this segment. I'm going to probably do, this is going to be the 181st video. My goal is to get to 200, and then once I get to 200, I'm probably going to be working with other algebra stuff, maybe college algebra or something like that. But I think that's all the AP calculus. You know, I may come back to it from time to time, just to kind of keep my mind sharp. But all in all, I'm just mainly it's something that I want to give to you. Okay, ladies and gentlemen, this is KP the Math G getting ready to sign off. If you haven't subscribed, please do so. If you would like to hit that like button, please do so. If you'd like to make a comment, do so. And again, I'm not going to say do that. If you don't want to do it, that's fine with me. But at least I want you to be able to get this. Okay, and that's what it's all about, is you getting it. Well, I think I hear my alarm go off to get me some pizza. I got a pizza in the oven and got the timer on, and I think I can hear the timer going off. But anyway, uh, if you were here, I wouldn't have much to give, so but I'll give you something. Anyway, that's just a side joke. My jokes are a little bit lame anyway, but my wife will testify to that. That yeah, he's got some lame jokes, but she still loves me. That's all I can ask for. All right, anyway, ladies and gentlemen, KP the Math G signing off. Have a great, great day.